We will now introduce TAIYO Yuden's multi-layer piezoelectric actuators for haptic technology. We will begin by explaining a piezoelectric body. When stress is applied to a piezoelectric body, electrical polarization takes place in proportion to its intensity, causing a voltage to be generated. This is called the piezoelectric effect. In contrast, when a voltage is applied to a piezoelectric body, a displacement takes place in proportion to the voltage. This is called the inverse piezoelectric effect. Piezoelectric actuators function by the inverse piezoelectric effect, and when an AC voltage is applied to a piezoelectric actuator, it is subject to stretching vibration. Here are some features of our actuators. With our material technology, we can achieve low permittivity, high electromechanical coupling, and improved material properties. In addition, our multi-layer technology, acquired through the production of multi-layer ceramic capacitors, can optimize multi-layer structures and make design-optimized applications. We have been able to develop actuators with high displacement and low power consumption by simulating the optimization of a multi-layer structure with our own material and multi-layering technologies. Haptic functions are typically classified into notification by vibration, force feedback by reaction, and touch by friction. At present, notification and force feedback type haptic functions are implemented. In the future, touch type haptic functions will be in demand. This graph illustrates the responsiveness to the driving frequency by actuator type. The horizontal axis shows the drive frequency, and the vertical axis shows the responsiveness. Various types of actuators are used for haptic functions. For notification type haptic functions, eccentric motors and electromagnetic actuators such as linear resonance actuators are used. Force feedback type haptic function and electromagnetic actuators use piezoelectric actuators. For touch type haptic functions, piezoelectric actuators are needed because they support a wide range of driving frequency and offer a quick response. This slide shows the results of simulating actuator element structures. The horizontal axis shows the frequency, and the vertical axis shows the displacement amplitude of a panel. You can see that larger displacement amplitude has higher haptic performance. The element thickness of 0.6 mm makes larger amplitude and has better uniformity in the amplitude distribution of the panel. From this simulation, we can say that the larger the amplitude area with striped and uniform structure, the better haptics performed. This slide shows the vibrational measurements of an observed panel under the simulation conditions of the previous slide. You can see that the amplitude at the center of the panel is large like those in the simulation. Measurements of the out-of-plane vibration can help us grasp the vibration mode and amplitude distribution, aiding in the development of high-performance actuators. This slide demonstrates the basic principle of the touch-type haptic function. The illustrations show cross-sectional views of a touch panel. Piezoelectric actuators are placed at the edge of the panel on the reverse side. When the actuators are driven with an ultrasonic frequency, standing waves are excited on the panel surface as illustrated. When you touch the panel while the standing waves are excited, the kinetic friction changes and the touch feels smooth. The touch varies with the amplitude of the standing waves and other factors relating to actuator driving controls. This picture shows the visualized amplification on a 12.3-inch panel with liquid when a sine wave of 36 kHz, 25 peak-to-peak voltage is applied to piezoelectric actuators. As shown, the entire surface is vibrating, and when touching the panel, uniformed haptics can be felt. The variations of an element are shown here. TAIYO YUDEN has several variations designed for feedback function and for touch function in many sizes, including 53 by 8mm and 18 by 8mm. We can customize our actuators to suit customers' requirements. For driving voltage, we offer 96 peak-to-peak voltage, 48 peak-to-peak voltage, 24 peak-to-peak voltage, and more. Today, there is an increasing number of vehicles featuring onboard control switches that are being implemented on flat panels with touch sensors. In vehicles where safety is critical, feedback on a switch operation is considered indispensable. At the same time, the number of home appliances with touch panels is increasing as IoT advances. In addition, demand for feedback functions will surely rise in the future for VR devices, smartphones, and home appliances equipped with touch panels. Thank you for listening.